Okay, hello children. Your Vanashri ma'am is back with trigonometry part 3. Now I will be doing another type of question with the square root. Okay, so prove that square root of 1 plus sin A upon 1 minus sin A is equal to secant A plus tan A. Okay, so again consider LHS. Consider LHS. So consider LHS, that is square root of 1 plus sin A upon 1 minus sin A. Now you have to multiply by 1 plus sin A. This is 1 minus sin A, so you will multiply by 1 plus sin A, like how in rationalization you used to do similarly. So what will you do? Multiply the numerator and denominator by 1 plus sin A, because here it is 1 minus sin A. So 1 minus sin A into 1 plus sin A. ये क्या किया हमने? Multiply numerator and denominator by 1 plus sin A. Okay, so what will you get? Square root of 1 plus sin A whole square. So this square root will go away under this root, isn't it? So upon, this is a minus b, a plus b, so it will become a square minus b square. So 1 square is 1 minus sin square a. This here what did we use? We used a minus b into a plus b is equal to a square minus b square. Okay, then this implies square root of 1 plus sin A whole square is, or you can write together, this is 1 plus sine A whole square, and 1 minus sine square A is cos square A. 1 minus sine square A is cos square A, isn't it? Because cos square A plus sine square A is 1. So from that we got. So this implies the square root will under square root. So this it will become 1 plus sine A upon cos A. Now this can be separated as 1 upon cos A plus sine A upon cos A. Why? Because cos A belongs to both. Okay, so this is 1 upon cos A plus sin A upon cos A. Now 1 upon cos A is sec A and sin A upon cos A is tan A, which is nothing but RHS. So therefore LHS is equal to RHS, hence proved. Okay, so the next two sums, one of them is a board sum, but it is a similar sum. So homework for you. This is also board question. Root of 1 minus cos A upon 1 plus cos A is equal to cosec A minus cot A. It is similar to the above sum. You have to multiply by 1 minus cos A because it is plus here. So you will get 1 minus a cos A, 1 minus cos A whole square, and here you will get 1 plus cos A into 1 minus cos A, that is again A plus B, A minus B formula, and same way you will do it. So this is homework for you. Another question, similar one is prove that root of 1 minus cos A upon 1 plus cos A is equal to sin A upon 1 plus cos A. This is also board question, same year, 2000. Okay, so this is also same way you will multiply with, here only difference is you will multiply with 1 plus cos A, so you will get 1 plus cos A whole square in the denominator, and 1 minus cos A into 1 plus cos A, that is A plus B, A minus B, will get in the numerator. Okay, try and do it, you will get it. Okay, you have to, only hint is multiply the numerator and denominator by 1 plus cos A. You will get it. Okay, then the next question I am doing, prove that root of 1 minus sin A upon 1 plus sin A is equal to cos A upon 1 plus sin A. So multiplying the numerator and denominator by 1 plus sin A, you will get 1 minus sin A into 1 plus sin A upon 1 plus sin A into 1 plus sin A. So this will become square root of, this is of the form this is of the form A minus B into A plus B. So it will become a square minus b square. So 1 minus sine square a upon 1 plus sine a whole square. So here we have used the identity a minus b into a plus b is equal to a square minus b square. So now 1 minus sine square a is cos square a. So square root of cos square a upon 1 plus sine a whole square. Okay. So here we have used 1 minus sine square a is equal to cos square a. As I have told you earlier, this is from the identity sine square a plus cos square is equal to 1. So 1 minus sine square a is cos square a. Okay. So now if you remove the square root, this will become cos a this will become cos a upon cos a upon 1 plus sine a. The whole square will go. Okay, when you take the square root. So cos a upon 1 plus sine a. That is nothing but this is the RHS. Cos a plus upon 1 plus sine a. Therefore, LHS is equal to RHS, hence proved. Okay. So the next two questions are similar to this. Next question is prove that this is homework for you. Prove that 1 minus cos square a upon 1 plus sine a is equal to sine a. This is a board question. It came in the year 2001. So again you will have to consider the LHS. Then you will do the LCM or you will do the cross multiplication. Then you will get sine square a plus cos square a. So that can be written as you will get 1 minus cos square a plus sine a upon 1 plus sine a. That is when you multiply this. Okay, 1 plus sine a minus cos square a. So then 1 minus cos square a can be written as sine square a. Then you will get sine square a plus sine a upon 1 plus sine a. Then you will take out sine a common. So if you take out sine a common, you will get directly what you want. Right. Okay. Next question is also homework, which came in the year 2002. That is 1 upon sine a plus cos a plus 1 upon sine a minus cos a is equal to 2 sine a upon 1 minus 2 cos square a. Okay, 2 sine a upon 1 minus 2 cos square a. Okay, so now this is all similar like cross multiplication. You will multiply this with this with this upon this into this. So a plus b, a minus b you will use, and then straight away you will get by using 1 minus cos square a equal to sine a, you will get it. So it's very easy, nothing new. We have done several sums of this type, so try it. Okay, then now the next two sums are also similar routine, so do it as homework. Prove that sine a plus cos a upon sine a minus cos a plus sine a minus cos a upon sine a plus cos a is equal to 2 upon 2 sine square a minus 1. So here also you will simply cross multiply and then keep simplifying. You will get by using sine square a plus cos square is equal to 1, you will get the answer. Okay, try it out. The more you practice your own, then only you will be able to really do it well. So cot A plus cosec A minus 1 upon cot A minus cosec A plus 1 is equal to, this is proof that, is equal to 1 plus cos A upon sin A. So here you have to write cot as cos upon sin, and you have to write cosec as 1 upon sin. Then you will get it easily. Try it out. Okay. Or let me just show it to you, because it is little slightly longer. So this I will do it classwork only for you. Okay. See, first let us write down as it is required. So we will convert this cot and cosec. So consider LHS. Let us write down. Cot A can be written as cos A upon sin A plus cosec A can be written as 1 upon sin A minus 1 upon, again cot A can be written as cos A upon sin A minus cosec A can be written as 1 upon sin A plus 1. Okay, so here what did we use? We have used cot A is equal to cos A upon sin A, and we have used cosec A is equal to 1 upon sin A. These two we have used. Okay, now we will cross multiply this. What will happen? This will be, when you multiply, this you have to take sin A. Now there are three terms, so you cannot take it as cross multiplication, so you have to take the LCM. So this will become, sin A is the LCM, so it will become cos A, okay, then plus 1 minus sin A. Cos A plus 1 minus sin A upon sin A, and here also the LCM is sin A, so here it will be cos A minus 1, then 1 is there, so sin A. So when you multiply by the reciprocal, cos A plus 1 minus sin A upon sin A into sin A upon cos A minus 1 plus sin A. So this sin A cancels. So what we are left with? We are left with cos A plus 1 minus sin A, put it in brackets, upon cos A minus, if you take out minus common, then this will become 1 minus sin A. Okay, so this is plus, this is minus. So whenever it is like this, you have to multiply by the numerating factor. So this is minus here, so you will multiply by plus. So that is how sorry, how in rationalization you used to do. If a plus b is there, you used to multiply numerator and denominator by a minus b. If a minus b is there, you used to multiply by a plus b. Similarly, we will multiply in the numerator, multiplying the numerator and denominator by cos A plus 1 minus sin A. This 1 minus sin A entire thing is like they are considering as one term. So it is cos A minus 1 minus sin A. Now it will multiply with cos A plus 1 minus sin A. So what it will become? It will become cos A plus 1 minus sin A into again cos A plus 1 minus sin A upon here in the denominator we have cos A minus 1 minus sin A, and this is cos A plus 1 minus sin A. Did you get it? Did you follow? So now this is A plus B, A plus B. So this will become cos A minus cos A plus 1 minus sin A whole square, right? And this will be A minus B and A plus B. So it will become A square minus B square. So that way it will become cos square A minus 1 minus sin A whole square. Here we have used A minus B into A plus B is equal to A square minus B square. Okay. So now we will expand. 1 minus sin A whole square. Okay. So what we will get? Cos A plus 1 plus sin square A minus 2 sin A upon this is cos square A minus 1 minus sin square A. This is actually minus 2 sin A. Because of this minus it will become 2 sin A. Okay. So now cos this is now this sin square A can be written as this is actually cos square A. So this cos square A plus sin square A is 1. Okay. So implies 1 plus 1 minus 2 sin A upon now this here down you will get this cos square A can be written as 1 minus sin square A, then again 1 minus sin square A plus 2 sin A. Okay. So this will be 2, 1 plus 1 will become 2, 2 minus 2 sin A. Okay. And here we will get 1 and minus 1 will get cancelled, and this is minus sin square A and minus sin square A is minus 2 sin square A and plus 2 sin A. So now here if you take out 2 common it will become 1 minus sin A upon here if you take out 2 sin A common then you will get 1 minus sin A, right? See, this 2 sin A take out common, so 1 and minus sin A will remain, right? Now 1 minus sin A, 1 minus sin A gets cancelled. Hold on children, I think I have gone somewhere wrong. I'll cross check the steps and I'll come back. Okay children, here I made a mistake here. While expanding, I have to expand this also 1 minus sin A whole square. isn't it? So that I went wrong. So I'll be doing from here again. Here I went wrong. Okay. See, here we have to expand carefully. This is cos square A plus 1 minus sin A whole square. This is A square plus B square plus 2 cos A into 1 minus sin A. Agreed? This is A square plus B square plus 2A. A is cos A, B is 1 minus sin A. Upon this is cos square A minus, and this when you expand, 1 plus sin square A minus 2 sin A. Okay. Now we'll expand this. So now we have to expand this again separately because this is 1 minus sin A whole square. Okay, so this will become cos square A plus 1 plus sin square A minus 2 sin A, then plus 2 cos A minus 2 cos A sin A. Why? This 2 cos A is multiplying both. So 2 cos A into 1 is 2 cos A. 2 cos A into minus sin A is minus 2 cos A sin A whole upon this one will become cos square A minus 1 minus sin square A plus 2 sin A. Okay. We just change the signs because there is a minus sign. Okay. So now this implies this cos square A and this sin square A together becomes 1 plus 1, then minus 2 sin A plus 2 cos A, unknown numbers. 1 cos square A plus sin square A is 1 plus 1. Then you have minus 2 sin A plus 2 cos A minus 2 cos A sin A upon. Okay. Now you have here cos square A. If you take out minus common, then this will become minus 1. No, there is no meaning in doing that. Okay, let us continue as it is. So cos square A minus 1 minus sin square A plus 2 sin A. So on the top it will become 2, numerator 2 plus 2 sin A plus 2 cos A minus 2 cos A sin A. Okay, upon here you will get cos square A minus, if you take out common, so it will become 1 plus sin square A plus 2 sine A. Okay, so this will become 2 plus 2 sine A plus 2 cos A minus 2 sine A cos A upon this will become cos square A, okay, minus this is 1 plus sine A whole square, isn't it? Why? Because here it is minus 2 sine A. I have by mistake written plus, so I corrected as minus. So 1 plus 1 2 minus 2 sine A plus 2 cos A minus 2 cos A sine A upon cos square A minus I have taken out common, so it becomes uh, cos square A minus of 1 plus sine square A minus, okay, this one will become minus because I have taken out minus common. So this will remain 2, okay, then this is again minus 2 sine A plus 2 cos A minus 2 sine A cos A whole upon cos square A. Now this I will take it back. I will remove the bracket. So minus 1 minus sine square A plus 2 sine A. So this will become 2 minus 2 sine A plus 2 cos A minus 2 sine A cos A whole upon 1 minus sine square A. This cos square A I am writing it as 1 minus sine square A. Again minus 1 minus sine square A plus 2 sine A. Okay. So now here I will take out 2 common throughout. So this implies 2 into 1 minus sine A plus cos A minus sine A cos A whole upon this will become 1 minus sine square A now this will become, see, 1 and 1 plus 1 minus 1 will get will get cancelled. So minus sine square A minus sine square A will become minus 2 sine square A and plus 2 sine A. Now from the denominator also we will take out 2 common. So 2 into 1 minus sine A plus cos A minus sine A cos A whole upon, from the denominator if you take out 2 common, let me write the first plus sign first. So sine A minus sine square A. Okay. So now minus sine A cos A, sine A plus cos A. So now here I can take out cos A common from these two. So this will become 2 into 1 minus okay, 2 is there. Okay, now 1 minus sin A plus here if I take out cos A common, it will become 1 minus sin A. Okay, whole upon, now I will take out sin A common. So 2 into sin A, if I take out common, 1 minus sin A. Okay, now again 1 minus sin A, 1 minus sin A is common. So, and this 2 gets cancelled. So 1 minus sin A, if I take out common, 1 plus cos A whole upon sin A into 1 minus sin A. Now 1 minus sin A, 1 minus sin A gets cancelled. So this implies 1 plus cos A upon sin. So this is equal to your RHS. But in this case, the RHS they can also give you as cosec A plus cot A. Why? Because 1 upon sin A is actually cosec A and cos A upon sin A is cot A, and which we have already done in some other sum. But here since they have asked us till here, then this happens to be RHS. So we will stop here only and we will say therefore LHS is equal to RHS, hence proved. This is a little lengthy sum and you have to be very careful while doing the calculations. 1 minus here there you may go wrong like I have done here. Minus, I forgot this minus. So entire sum goes wrong if you do small error also. So you have to be very careful. That completes our topic. So practice more sums, and if you have any doubts, ask me. I will clarify. Thank you. Take care.